Thank you for coming back. Bernoulli's principle. Now this is a very interesting and fun principle. I will show you some exciting stuff afterwards. Physics is fun, alright? It's really funny at times when you study physics. And you have to relate the fun part to the concepts, to the principles. And Bernoulli's principle is one such concept that you must really understand it, and after that you find that you will be able to write about it, to explain it. And once again, to improve your physics, you must get into the habit of doing output revision. So I am encouraging you this afternoon to do output revision with me in this section on Bernoulli's principle. Now at the end of this lesson, you will be able to understand what Bernoulli's principle is all about. And secondly, you will be able to explain Bernoulli's principle. You can explain to somebody, you can write it down. Take a look now. Interesting diagram. You have seen this on the road. The canopy of the lorry, something happens to it, and when the lorry is moving at high speed. It's really funny, isn't it? And this happens in class when I was teaching them something else. And when I suddenly saw this phenomenon, I quickly stopped what I was teaching, and I took photographs, I took videos, and after that I asked the students about it. Because this is actually physics in action, impromptu. Alright? So this is a very exciting photograph, and I'm going to ask you a few questions concerning the lorry and concerning our friend here who has something happening in his shirt. Alright? So I have diagram 1.1, diagram 1.2. Diagram 1.1, we have the lorry moving at high speed. In diagram 1.2, we have the ceiling fan blowing at high speed, spinning and spinning. Alright, and we see this particular young man, the student, having a certain kind of phenomenon around him. So I have two questions to ask. A. What is the similarity between diagram 1.1 and diagram 1.2? And my second question is this. Explain the phenomenon in diagram 1.2. I chose 1.2 over 1.1 for some reason. Alright, first question. What is the similarity? Alright, let's do some writing now. Are you ready with your pens, your notebooks? Okay, so this is the picture that we have. And this is also to encourage you to study correctly in preparation for examination, because very often you are asked to compare and contrast situations. You will know how to observe and what to write. Alright, so what is the similarity? Let's write down. Okay, I see that you are writing down. The canopy of the lorry, it bulges. And the shirt of the student, it also bulges. Alright, so that is the similarity. Okay, so we are going to write down 1A. Okay, we will say that the lorry, the canopy of the lorry, I just write canopy will do. The canopy bulges. Okay, this is in diagram 1.1. Alright, and then in diagram 1.2, we have the boy, his shirt also bulges. Alright, alright, so 1.1, 1.2. Alright, now, as you see the way I just answered the question, it is a very short answer. We do not have to tell long stories. Just answer straight to the point. Just say that the canopy bulges. Put down there, diagram 1.1. And then you say that the shirt bulges. and just mention it is in diagram 1.2. Alright, so we have answered the question. Now the second part is this. Explain the phenomenon in diagram 1.2 in the case of the boy. In other words, I am asking the question, why is it that the shirt of the boy bulges suddenly? You know, some of you are surprised, isn't it? How come? What happened? Alright. So, to explain it, I would recommend that we draw a simple diagram. Because a picture paints 1,000 words. So, you use a diagram, a sketch, and then based on the sketch, you can explain. Indirectly, I am also teaching you how to answer questions. Alright? Now, I write down B. Okay. I prefer to use this. Alright, now I'm sketching. Alright. This is the guy, right? And this is his shirt. Alright. The shirt bulges, alright? Okay. So, how do I explain it? It's very simple. What I'll do is this. This is outside, alright? The fan is spinning at a high speed. Alright, so what happens? Okay, so we have high speed, the air is moving very fast. Alright, so I can label it air at high speed. High speed or high velocity, both are accepted. So air at high speed outside. So I'm going to use symbol. Alright, VO. VO is the velocity of the air outside. O for outside. Alright. So in other words, VO is high. Alright. What about inside? That is the shirt of this guy. Now inside, what happens to the velocity of the air? Anybody? Alright, anyone wants to answer? Inside the shirt, the velocity or the speed of the air is low. Alright, so VI, the I is inside. Alright, is low. So far so good? All understand, isn't it? Alright. What did Mr. Bernoulli say? He says that when we compare two regions, alright, when the speed of the fluid, in this case it is air, when the speed of the air is high, the pressure is low. Alright, so pressure, I write down pressure. This pressure is the pressure outside, or the pressure is low. Alright, or I can just say low. Now inside where the speed of the air is low, according to Bernoulli's principle, the pressure is high. Now you will notice that I don't even take the whole principle and write down in words for you. That you can do it yourself. But I am explaining the principle, I am explaining it to you so that you can understand it and you can explain to others. Alright? So, V inside is low, therefore, the pressure inside, that is underneath the shirt, is high. Alright, so the pressure inside is high. Okay? So, in other words now, you just compare. Alright? The pressure is low outside, but the pressure is high inside. Alright, I use another color. Sorry. Inside, the pressure is high. Outside, the pressure is low. And because of a difference in the two values of the pressure, there is a net pressure pushing the shirt out. You see the point? Okay, so there is a net pressure pushing, all right, because the pressure inside is bigger than the pressure outside. Therefore, it pushes it out. And this explains why, the shirt bulges. Now, the same principle explains the behavior of the canopy in the lorry. It's exactly the same. But I will just stop here and you can go back and try out on your own. Do output revision and explain why is it that the canopy of the lorry also bulges when it is moving at high speed. Alright? Perhaps I will give you a minute to write down. And after that, I will check with you with my answer. See whether you have got it. Alright, now, I think you have understood this. So I will just mention the lorry as an extra bit of revision for you. Alright? So I have the lorry. Alright, so this is the canopy. Alright, so the canopy part, it bulges, isn't it? Here. Alright, so the canopy, it bulges. Okay, and this lorry is moving at high speed. So when it goes at high speed, what happens? The air is moving at high speed in the opposite direction. Okay, so once again, the velocity or the speed of the air outside, alright, VO, is high. Alright, is high. Alright, so therefore, according to Bernoulli's principle, what happens to the pressure outside? It is low. Alright, the pressure is low. Now inside, velocity of the air inside, I, is low. And according to Bernoulli's principle, where the velocity of the air is low in a region, the pressure is high. Alright, so the pressure inside is high. Alright, and it's because of this that you find that the canopy or any part where there is a canvas, alright, now let's say even the back part, if it is a canvas, alright, if it is a canvas, you will find that it will bulge out, alright, because of the difference in pressure. Because inside the pressure is high, outside the pressure is low. So it pushes out. It pushes out. There is a net difference in the values of the pressure. So it's kind of interesting, isn't it? All these phenomena happening before our eyes. Every day you see it. You can see it on the road. You see it everywhere you go. Alright, so you go back home, look at what Bernoulli's principles say, the statement, write it down in full, and this is the explanation. Alright? Now, so with that, I'm very sure that by now you have understood Bernoulli's principle better, having worked it out, having sketched cartoons and diagrams. Alright? So I would like to say thank you very much for being with me, and I'm Uncle Pang here, and may God bless you.